Okay, this video is just a quick review on chain rule. It's not all the problems that we did in class, but it's a couple of them, just so you can look back and see again what chain rule is. Basically, chain rule is how you are able to take a derivative of a composite function. So, for example, if we have a function that's f of g of x, if I want to know the derivative of that, and in fact this should probably be more like this. If I want the derivative of this whole thing, we would take the derivative of the f function first and leave g alone, and then multiply it by the derivative of the inside, which is g prime of x. Okay, so let's try to use that with these two examples here, and then I'll do a couple more. First off, the outside would be cosine. So if I want the derivative of that, I would say that the derivative of y with respect to x is equal to the derivative of cosine is negative sine, and then we do not touch the inside. We'll call this the inside. This is like your g of x. This stays the same. Okay? Now we multiply by the derivative of the inside. So now what's the derivative of the inside? Should be 2x plus 1. And that's the final answer. It's this chunk times 2x plus 1. Pretty simple. Again, you just have to remember that when you take the derivative of a trig function, you don't also take the derivative of the inside. You leave that alone until the next time. Alright, so here's where it gets a little more complex. Find the derivative of tangent of 5 minus sine of 2t. So there's going to be actually two chains here, or three chains, because we have the sine, and then it's not just the sine of t, it's 2t. So we're going to have to take the derivative of that inside as well. So first thing we do is we take the derivative of the outside. So the derivative of tangent is secant squared of, and then we leave everything the same. So this is staying the same. Okay? Times. Now we are going to take the derivative of the inside here. Again, this is now in there, so we're not going to touch the 2t. Derivative of 5 is 0, so that doesn't matter. Derivative of negative sine is negative cosine, because the derivative of sine is cosine. So negative cosine, we leave the inside alone. And then, finally, we take the derivative of the inside of this trig function. So the derivative of 2t is just 2. Okay? So, this is the derivative of tangent of 5 minus sine of 2t. It's that whole thing. And you can leave it like that for now. That's all. It's fine. Alright, let me do a more difficult one. Let's try example 3. I'll call it, I'll say I have y is equal to x over the square root of 1 minus x squared. So this kind of incorporates not only chain rule, but we're going to have to use product rule with chain rule, because I want to rewrite this so I can take the derivative of this. So I want to find the derivative, by the way. Okay, so I'm going to rewrite this. This is the same thing as 1 minus x squared to the 1/2, and I'm going to bring it up. So this is saying that y is equal to x times 1 minus x squared to the negative 1/2. Okay, it's easier to write things that way. You could do quotient with the chain, but I like to do product rule. So now we have product rule. So we're going to use product rule here. And when we do the derivative of this piece, we're going to have to do a chain. So, that should be just rule. And then, alright, so I'm going to keep the first one the same. So dy dx is equal to, keep that the same, x times the derivative of this red piece that I've underlined. So to do the derivative, we first do the power rule. Remember? Pretend this is just x to the negative 1/2. This would come down, and it would be negative 1/2. We leave the inside alone. And this goes down a power, so this now becomes to the negative 3/2. Times, we now have to take the derivative of the inside. The derivative of the inside here is just negative 2x to the first. Okay, so that is the first part of product rule. However, product rule, you have to then add that to the derivative of the first piece times the second piece. Well, that's pretty simple. The derivative of x is just 1, and then we multiply it times 1 minus x squared to the negative 1/2. Okay? So if I try to simplify this, which I will do here, I can take this negative 1/2 and this negative 2 and cancel those out, and I'm left with an x times an x because of this x over here. So I get dy dx. X times x is x squared times this piece plus. Now this is where, I mean, technically that's fine, this answer, but just to show you what else you can do with this, because sometimes the book answers are a little different or they have factored it more, there is a piece you can take out of both of these terms. We have a 1 minus x to the x squared to the negative 3/2 and to the negative 1/2. Okay, so if I take out 1 minus x squared to the negative 3/2, I can say that the derivative, and all I'm doing is factoring out this piece out of both of them, both terms. So the piece becomes 1 minus x squared to the negative 3/2, and when I take it out of this piece, I'm left with an x squared plus, here, when I have, remember, when you multiply like bases, you add the exponents. So in order for this to add to something to get to a negative 1/2, we need to have to the first power. And so by taking that out, this is now the first power over here. We don't care. So that means that this is all not really in parentheses anymore. And then this green piece, x squared plus 1 minus x squared, is just a 1. So that means that because we pulled this out, the other piece cancels to a 1, and we just get 1 minus x squared to the negative 3/2 times 1, which is, again, the same thing. So that's what you can do with those. Alright, we can do the same thing with parametric curves. Just so you guys know, I'm going to do this all in one lesson. So for parametric curves or equations, using chain rule, we can come up with the equation that the change in y with respect to x is equal to the change in y with respect to t over the change in x with respect to t. So basically, when you have two equations, you need to take the derivative of both of them with respect to t and then divide them, y on top. So let's do a quick example. Find the line tangent. I forget which example. I think I'm on 4 now. To a curve that's defined parametrically by the equations x equals secant of t, y equals tangent of t, and t only goes between negative pi over 2 to pi over 2 at the point root 2 comma 1, where t is equal to pi over 4. This part is just the part of the curve, so we're not actually going to run the thing through that. Alright, so let's do that. I'm going to do this so we can see it. There we go. So in order to find a line tangent to a curve, we need to find the slope, and hopefully by now you guys know that to find the rate of change you need to take the derivative. However, this is a parametric equation, so we have to take the derivative of x and y with respect to t first. So that's the first thing I'm going to do. dx dt. Well, the derivative of secant is secant tangent, so we have secant of t times tangent of t. So that's the change in x over t. If I want to find the derivative of y with respect to t, I take the derivative of tangent, and that becomes secant squared. So we have that, and then we can find the derivative, the rate of change of the actual equation, or the slope, the rate of change of y with respect to x, by taking the y piece with respect to t, which is secant squared of t, and then divide it by the x change in x with respect to t. So if you notice, we can then simplify this a little bit, or you can just plug in numbers if you want. So this goes away, becomes 1 secant on top. So we get that the slope of this equation is equal to secant of t over tangent of t. Here's where your parametric here's where your trig has to comes into play here. I want to evaluate this when t is pi over 4. So I have secant of pi over 4 over tangent of pi over 4. Well, tangent of pi over 4 is simple because remember at pi over 4, cosine and sine are both root 2 over 2, which means that tangent is 1 because when you divide that, you get a 1. Secant is 1 over cosine. Okay, so if cosine is root 2 over 2, secant is 2 over root 2. And then if you simplify this, you get 2 over root 2, which can simplify to just root 2, I believe. Yeah, because that'll cancel. So we get that the slope is root 2. So now we can write the equation y is equal to, or actually if I'm putting it into point slope form, it's at 1 and root 2. So y minus 1 is equal to the slope. And again, this is for a tangent line. If it was a normal line, we would flip this back over and make it a negative. Or I guess opposite sign if it was already negative. X minus root 2. And there's my equation. Okay. And then the last thing I'm going to do is a chart problem. Again, it's just 2 days of notes in one. But I'm taking a few. I'm not doing every problem here. So if I give you a chart, and I say that I give you a bunch of numbers for these functions, we can use chain rule and numbers to find the derivatives without, or we can use the chart to help us find our derivatives, I should say. So when x is 2 and 3, the function is 8 and 3, 2 and negative 4, 1/3 and 2 pi, and negative 3 and 5. Okay, so that's the table. We're going to use that for everything. So these are the problems I want to know. So for part A, I want to know what is, and I want all the derivatives of these actually. So find the derivatives at the given value. So I want to know what the derivative of 2 times f of x is when x is equal to 2. So think about your rules. We just have f of x. We don't have a chain rule situation here. When you do a constant times a derivative, it's just the constant times that derivative. You don't have to do anything here. You leave the constant the same, so the derivative is 2, and then it happens to be f prime of x. Well, I want to know when x is 2. So when x is 2, you look at your chart, when x is 2, what is f prime of x? It is 1/3. So f prime of 2 is 1/3, so we can just say that the derivative is 2 times 1/3, or 2/3. Okay, so that's how you use the chart. What about f of x times g of x? When x is equal to 3. Okay, so the first thing we do is take the derivative. Well, this is a product rule situation because we have 2 different functions being multiplied. So I'm going to keep the first one the same, multiply by the derivative of the second, and there's no chain rule going on because it's just of x, plus f prime of x times g of x. Now I look when x is equal to 3 and plug in all the numbers when for the functions when x equals 3. Technically, I should rewrite this as f of 3 times g prime of 3 plus f prime of 3 times g of 3. And then you go up here and go, well, when x is 3, what is the function? The function's 8. So I get 8 times, when you're at 3, what is the derivative of g? It's 5, plus f prime is 2 pi, randomly, and g is negative 4. So the derivative becomes 40 minus 8 pi. 40 minus 8 pi, unless I did something wrong, which I did, because f of 3 is not 8. That's f of 2. Sometimes you look at the table wrong. So this should be 15 minus 8 pi. 3 times 5. And that is now correct. So just be careful. You know, we all make mistakes. Just be careful reading the table. Make sure you're looking at the right row when you do that. So here's one where we're going to have chain rule. We'll do C and D, and then we'll be done with the notes of this video. So I want to know what the derivative of f of g of x is when x equals 2. Now this is a composite function, which means we have to use chain rule. So to take the derivative of this, we first take the derivative of the outside, f prime of g of x, and then we multiply that by the derivative of the inside, which is g prime of x. So now I want to do this when we're at 2 again. We're back at 2. So I have f prime of g of 2 times g prime of 2. Well, we don't know what f prime is yet because we actually have to figure out what g of 2 is to put a number in here. So if I go up here and look, g of 2 is 2. So this turns into, and actually let me look at what g prime of 2 is. G prime of 2 is negative 3. So this turns into f prime of, this turned into just a 2 times negative 3. Now I go back to the chart and see what is the derivative of f at 2, and it's 1/3. So I get 1/3 times negative 3, and that means that this becomes negative 1. Okay? And finally, we'll do one more chain, and then we'll be done. If I give you something that's 1 over g squared of x, okay? This has to be a chain because that whole function's being squared. It's not just x squared now, it's a function being squared. So, and this will be at x equals 3. So first things first, I like to rewrite these if it's just one piece, bring it up, write it as a negative exponent. So this becomes g of x all to the negative 2. So to take the derivative of this, you first take the derivative of the the outside, which is power rule. So we multiply the negative 2 down. So negative 2 comes in front. We leave the inside alone. Remember, if you've done the one rule, you don't change g prime of x yet. This whole thing is now to the negative 3rd. Actually, let me change the color on that so we know what we changed for that piece. That's a negative 3. Times, we're now taking the derivative of the inside, which is g prime of x. So here is the derivative. So now we can plug in numbers when x is 3. So we have negative 2 times g of 3 to the negative 3rd times g prime of 3. Look at the chart. We need g prime of 3 and g of 3. So here's 3. G of 3 is negative 4 and 5 for g prime of 3. So we get negative 2 times negative 4 to the negative 3rd times 5. Remember, a negative exponent flips this down to the bottom. Negative 4 to the 3rd power, positive 3rd power, is a negative 64. So this becomes negative 2 over, this whole thing goes below it, and it becomes negative 64 times 5. And when you simplify that, that becomes 5 over 32. So we use chain rule to get the expression we needed to sub in the numbers for, and then we use the table to get our numbers. Okay? So that's kind of a crash course on how to do some problems with chain rule. It's a very powerful rule you will be using all the time.